All right, today we are moving on from section 3.2 and starting section 3.3, Systems of Linear Inequalities. I really like this section because it's drawing on several skills that we've been building throughout the year. First of all, inequalities that we might remember from chapter 1, linear equations, which we remember from chapter 2, and then linear systems, which we just have been studying in section 3.2 and 3.1. So we're using a lot of skills in this particular section. All right, here are the learning goals. First of all, I'd like you to be able to graph linear inequalities and find their solutions, and then graph systems of linear inequalities and find their solutions. So we're dealing with just one line by itself. It happens to be an inequality, and we'll discuss what that means in a second. And then, of course, systems are going to be more than one. So graphing one by itself and then more than one together. Here's our scale for this section. I hope nobody is here at a 0. I have no idea what an inequality is because we've been talking about those for a little bit now. And then I want you to get all the way to a 4, which is given the graph of a system of linear inequalities, I can interpret the boundaries of an area to determine solutions and restrictions. Here we go. All right, since we can already graph lines, we can now graph inequalities, and it is really easy because they really look the exact same. The only difference here is that we're going to be using those inequality symbols that you've seen before. This one is less than or equal to, greater than or equal to, less than, and greater than. The properties of inequalities also apply here. So if you remember, kind of the big idea from section 1.4 was that if we multiply or divide each side by a negative number, we will have to flip the sign. And that same property is going to apply here as well. So be on the lookout for that, just as a reminder. Here's an example of a linear inequality. This one in particular is in standard form, which we're already used to. But the inequality part is just here with the symbol less than or equal to. Similarly, we can also have linear inequalities in slope-intercept form. This one here, y greater than or greater than 2x plus 1. All right, here are the steps that we're generally going to be following today. First thing we're going to do is decide whether or not the boundary line is included or excluded from the solution. So similar to when we were doing just regular inequalities like x is greater than 3, we first had to decide, okay, are we going to choose closed dot or open dot? And similarly, in these types of situations, we have to decide whether we're going to include the line or exclude the line. And so what that means in terms of the graphing is, are we going to choose a solid line, meaning the same as kind of a closed dot, or a dashed line, which would be the same as an open dot? So for example, if we have these two symbols here, less than or equal to, greater than or equal to, we would choose a solid line. If we're given these two symbols here or here, less than or greater than, we would choose a dashed line. So the same way we have open dot, closed dot, we have dashed line versus solid line. The next thing we do once we make that decision is actually graph the line that we're given. We pretend it's just a regular line, just like we've been doing in chapter 2, and graph it as we would just a normal line. Finally, we have to decide whether or not the solution is above or below the line. And this idea is similar to how we decide whether the solution for a regular inequality, such as x is less than 3, do we shade to the left or to the right? So in that situation, x is less than 3, we would shade to the left. If x were greater than 3, we would shade to the right. And so we have to interpret less than and greater than on the coordinate system. So let me show you how that looks. All right, let's say that we were trying to graph this linear inequality, which happens to be in standard form. When you're given things in standard form, generally we want them to be in slope-intercept form, and that's because we're really concerned with what's happening to the y value, the output. So here, if we were to solve for y and put the inequality into slope-intercept form, we would get this. Y is greater than 1/2 x minus 1. So moving through with our steps from the last slide, first thing to do is decide, okay, am I going to have a solid line or a dashed line? In this particular case, we're going to choose dashed line, and that's because we see that the inequality is greater than and not greater than or equal to. So you can see here in this picture, they choose dashed line. The second step from our previous slide is to actually graph the line, and it's here already for you, but we can see where they're going here. They went -1 as our y-intercept and then counted the rise and the run up 1/2. Here they're telling us dashed line indicates that the line is not part of the solution, and again, it's the same idea as open dot versus closed dot. The last decision you have to make is whether or not you're going to shade above or below the line. And this is where the inequality really, you have to look at what y is doing. Here, because y is greater than the rest of it, we're going to shade above where the values of y are larger. Had this been less than, we would have shaded below. When you're doing this in your own work, it's not the case that you really have to shade as you would kind of in art class. In math class, really you can just use a series of light lines to show me this is where the solution is. So a scribble of any kind or like hash marks, if that makes sense. That's what we generally use to do these things when we're doing it by hand. So this over here is saying since it's greater than, we'll shade above. If it had been less than or equal to, we would have shaded below. So here we can try it again. This particular one again is in standard form, so we can solve for y to put it in slope-intercept form. When we do, we'll get this statement here. Y is less than or equal to -2/3 x plus 2. All right, so once again, the decision is, are we going to choose solid line or dashed line? And here, we're going to choose solid line because we see it's less than or equal to, not just less than. Second thing we do is graph this as though it were a regular line. Since it's in slope-intercept form, we graph the 2, and then we have our rise and our run, -2 and then over 3. Third decision to make is whether or not we're going to shade above or below. Because we see here that y is less than or equal to the rest of it, we're going to shade below where the values of y are smaller. And again, we can use a scribble or just kind of a series of light lines to indicate where our solution is. Here in the blue, they're showing us a test point. Now, always in algebra, we want to make sure that we're getting the solution correct. And to check your solutions in these types of problems, you can pick a test point anywhere within this region. They pick 0, 0, but really we could have picked -1, 1, or -1 up 2, 1, 0, anything down here. We could pick anything. Once we pick a test point, we can or plug in these values into the line to make sure it makes a true statement. So since 0 is for x and y, we can plug those into our original inequality. 2 times 0 is 0, plus 3 times 0 will give us 0 again. And we get the statement that 0 is less than or equal to 6. And that is a true statement. So we at least know that 0, 0, this point here, is within our solution. Here they're reinforcing the idea that the solid boundary line means that we have the line's part of the solution. So as a test point, we could actually pick something that's on this line here. We could pick 2, 0 right here, or 0, 2 up here, and then 3, 0 down here. And here they're showing us that we use the test point to see whether or not we shaded in the right direction. All right, so here we are trying it from the beginning again. They give us one in slope-intercept form, so again, we just run through the steps that we've been talking about. Step 1, is the line dashed or solid? Here we're going to pick a dashed line because we see that it is just less than and not less than or equal to. Second thing to do is graph the line. We see a y-intercept of -3, the rise and the run of 1/2, and so we'll graph it. All right, so here's our line. The final decision to make is whether or not we shade above or below. And again, we look to the inequality. Because y is less than the rest of it, we'll shade below, down here, where the values of y are smaller. And they're showing us the shading down here. Once again, we can use a test point in order to figure out, did we do it right? So here you could plug in, let's say, 4, -3, and we could see if that works. So here, if we plug in 4 in for x, we would get 2 minus 3. 2 minus 3 is -1. And we get the statement -3 is less than -1. And that is a true statement. And so we know that at least this point right here, 4, -3, is part of the solution. We know we did it right. All right, I want you to try these 3 on your own. Remember to watch out for this negative here. When you multiply or divide by a negative, you'll want to flip the sign. All right, here come answers. Number 1, the answer was B. 2, the answer was A. And 3, the answer was C. If you have any questions, feel free to ask one of your fellow students for help, or you can write it down in your notes, and we'll discuss it next class. All right, our last example for today is what happens with systems of linear inequalities. So systems of linear inequalities behave very similar to the systems of linear equations that we've been doing in section 3.2. All right, so here once again we just have 2 inequalities to graph, just like we would in section 3.1 when we had 2 lines to graph. And again, we'll probably want to put both of them into slope-intercept form so they're easier to graph. All right, so let me show you how generally this is going to work. For the first one, we are going to choose a dashed line here. The second one is going to have a solid line. For this first one, when we solve for y, notice that we have this negative here, so eventually the sign is going to flip, and we'll get y is greater than the rest of it. So for the first line, we'll shade above, and they show you here. So they left it in standard form, but if you were to solve for y, you would see that we would have y is greater than the rest of the inequality, so we'll shade above. And then again, because we have a greater than sign, not a greater than or equal to, we're going to choose a dashed line. Similarly, on the second line, we choose solid line, and since y is less than, we will shade below. So here they are. Generally, when we're doing these types of problems, we're going to graph them on the same coordinate system. They're just showing you these separately so that you can see eventually what's going to happen. If we were to put them on the same coordinate system, it would look like this. Now, just like with our discussion of graphing linear equations, we're looking for points or solutions that work for both lines. And so if these were just regular lines, we would be looking for this intersection here. But since they're inequalities, really we're looking for any overlap that they share. And the overlap in this case is the region in purple. Once again, we can pick a test point to see whether or not we got our solution correct. And here, a possible test point would again be 0, 0, but we could pick anything like -1, 2, something like that if we wanted to, or excuse me, -2, 2. They're counting by 2s here. Anyway, any test point in the region, and we can plug it in to both inequalities to see whether or not this solution will work for both. Here they pick the solution 1, 1, this one that would be floating here in this region, and they check it in both. So here's them checking, and surprise, surprise, it works for both inequalities. All right, now I would like for you to try these on your own, and as a heads up, this is a vertical line here. Vertical line, we're going to shade left or right, not up or down. And here are the answers. Number 1, the answer was A. 2, the answer was C.